Hey, welcome back to our topic of mixtures and solutions. And yesterday, if you remember, we learned all about mixtures, and see if you can remember the two types of mixtures. I'll make this a little quiz for you. And so the first question is, what type of mixtures are the least mixed? Did you say heterogeneous mixtures? If you did, you're absolutely correct. Give me an example of a heterogeneous mixture. Did you say tossed salad, or M&Ms, or PBJ? If you did, you're absolutely correct. You may have given a number of other examples as well, and that's fine. Now, the second type of mixture that we discussed yesterday are those that are well mixed together. Who can tell me the name of mixtures that are well mixed? Homogeneous mixtures are correct. Very good. And there are different types of homogeneous mixtures, and last one we mentioned yesterday was the solution. And the solution to the pollution problem is dilution. After today, you'll know exactly what that means. Or maybe you already know what it means, but it actually has nothing to do with our topic today. It just popped into my mind with the word solution. So maybe I just have a problem that needs to be solved with a solution. Different kind of solution. Why don't we just get into our notes here and finish up our notes for this week with today's discussion of solutions. What are they in real life? Well, solutions, technically speaking, are homogeneous mixtures. Now, I've underlined that word for a reason. Refresh your memory a little bit. Think about what homogeneous means. Same throughout. So a solution is a homogeneous mixture that is formed when one substance dissolves in another. And that is a key point when it comes to solutions. Solutions are homogeneous mixtures in which you've got one substance dissolving in another. And we're going to be talking over the next few minutes as to exactly what that actually means. So hopefully you've had enough time to copy that down, because we're about to get into talking about three words regarding solutions that are all very similar to one another. And it's going to be really important for you this week in particular to study these three words. Actually, four words if you include the word solution, because all four words are rather similar to one another, but there are nuances, there are subtle differences that exist between them that you're going to have to remember. So let's get right into the first one. Not that one. The first one of these terms. And that is a solute. A solute is not the same thing as a solute. A solute is a substance that is dissolved. A solute is the substance that is dissolved. And notice I have capitalized the letters in the word is, and I've done that for a reason, as you will see when we get through the other terms. So we're going to define these terms first, and then I'm going to try and give you some illustrations of these terms to hopefully make more sense to you. So a solute is the substance that is dissolved. The next term is a solvent. The solvent is the substance that does the dissolving. And again, notice what I did with the word does. You might want to write it the same way, because when it comes to quiz time and when it comes to studying for quiz time, solute is, solvent does. Those key words there will be really important in understanding. One quick little memory aid could be solute is a shorter word, solvent is a longer word. Is a shorter word, does is a longer word. That might be a way to help you remember which one is which. But I'll tell you what, I'm going to give you some bonus points if you can come up with a good memory aid to remember the difference between solute and solvent. Don't work on it now. Wait until I give you some examples of it. But then you can work on it, send them my way, and I'll give you some bonus points for it. All right? Because I love memory aids. You probably remember lots of them from last year, 7th grade science, and with the life science. All right, so solute is dissolved, solvent does the dissolving, and the next word is solubility. Solubility is a substance's ability to dissolve. Again, notice the capital letters, and also notice I've underlined them. You might want to go up in your notes right now and underline those words also, because it can help you when you're studying. Solute is dissolved. Solvent does the dissolving. Solubility, ability to dissolve. In fact, a good memory aid for solubility is it sounds like ability. Solubility, ability to dissolve. So now, let me give you some examples of these three terms to hopefully reinforce their meanings as we go ahead and prepare for tomorrow's lab activity. So, let's begin. Kool-Aid. Who doesn't like Kool-Aid? No, don't raise your hand. I don't want to know if you don't like Kool-Aid. When I was a kid growing up, Kool-Aid was like the rage, because we had these commercials in the 70s with the Kool-Aid guy, and he was like a big dude that looks just like this, and he'd like run through walls and stuff, and on the other side would be really thirsty kids, and he'd like give you a glass of Kool-Aid to cool you down, and boy, that was great stuff. A real sugary treat. Maybe that's how I gained my sweet tooth growing up, by drinking some sweet Kool-Aid, because back when I was a kid, we didn't have little pre-measured packets of Kool-Aid. We had like tubs of Kool-Aid, and you could like scoop after scoop after scoop of the Kool-Aid and put it into the water and stir it around until it was all dissolved. Whoa, wait a minute, what did I just say? We took one substance, put it into another substance, and dissolved it. Whoa, this sounds like even as a kid, we were making solutions. Yeah. If you've ever made Kool-Aid, for instance, then you too have made a solution by taking the mix, putting it into water, and dissolving it by stirring. Think about that for a moment in the context of these words that we just went over. So the Kool-Aid into water. My question to you is, which one would be the solute and which one would be the solvent? Which one is dissolved and which one does the dissolving? Think about that for a moment. Do you have an answer? So tell me now, what would the mix be, solute or solvent? Hopefully you said the solute, because that is the stuff that is dissolved when you put it into the water, which would be called the solvent. Solvent does the dissolving. So the water does the dissolving to the Kool-Aid mix, the colored sugar basically, that is dissolved. In fact, water is oftentimes called the universal solvent. In fact, you might want to make a note of that in your books. The universal solvent. Water is the universal solvent. Where do you want to write that? Over in the margin might be a good idea, okay? Universal solvent, what does that mean? Well, water here on planet Earth does a fantastic job of dissolving many, many other things. Now, it doesn't dissolve everything because, as you've heard it said, oil and water don't mix, and oil doesn't dissolve in water. But solids actually can dissolve in water, and that's why we call it the universal solvent. If you've ever been to the beach and you accidentally took in a mouthful of ocean water, you know that it tastes more than just water because there's a lot of stuff dissolved in ocean water. There are various minerals and salts and, well, various other substances that come from marine animals that are all dissolved in that ocean water. Because again, water is the universal solvent because it dissolves so many different things. But let's move on here. I got some other pictures. As many of you know, I am a self-professed chocoholic because I love chocolate. In fact, I love all things sweet because I have a major sweet tooth. And I want to tell you a little story here of when I was younger. You see, when I was younger, I used to raid the pantry for sweets. If there was chocolate in the house, like bags of chocolate chips, they wouldn't last long because, well, don't tell my parents, but I used to go into the pantry after school and I used to sneak the bag of chocolate chips into my bedroom and just devour them because I love chocolate. I hope none of you do anything like that. But there was something else that we had in the pantry as well, and it was the only way that my mom could get me to drink milk. See, I'm not really a big milk drinker. In fact, as an adult, I really don't drink milk at all. Lactose intolerant, if you know what I mean. Plus, I don't really like the taste of milk. Sorry for those of you who are milk lovers. But there was one way that my mom could get me to drink milk when I was a kid, and that was by putting some of that mix into milk. Not hot chocolate, but chocolate milk mix. In fact, we used to have these big canisters of Quick, Nestle's Quick. Ah, that was a favorite treat of mine too. I used to come home after school, pour a glass of milk, and into the milk I'd open up the Nestle Quick box. It was a tin box. And the instructions, I think, would say, add 2 heaping tablespoons of chocolate mix, put it into your milk and stir. So I would get, actually, I think it said 2 teaspoons, which are the smaller ones. So I'd get the big ones, the tablespoons. And if it said 2 teaspoons, I would take like 4 or 5 tablespoons and dump it into the milk. In fact, I couldn't fill my glass up all the way with milk because I needed a lot of space for the chocolate mix. I got to tell you, I was bad. Don't tell my parents, but I was really bad. I'd pour in so much of the chocolate milk mix that when I stirred it around, oh, that chocolate milk was dark brown. I put so much chocolate mix into my milk that I'd have to hold on to that spoon because when I was done chugging that yummy sweet chocolate, there was always a thick chocolate syrup on the bottom of that glass that I would need that spoon to scrape it out, and I would lick that spoon clean, and boy, just thinking of this, even as an adult, is making my mouth water. I loved my chocolate. But in that example of chocolate milk, what out of the two things, the mix or the milk, which one would be the solute? Hopefully you said the mix. Which one would be the solvent? The milk. So the milk does the dissolving and the mix is dissolved. But my story doesn't end there. It gets worse, believe it or not. Yeah, it gets worse. You want to hear what I did next? Again, don't tell my parents this, but one time I came home and I had finished up all of the Nestle Quick chocolate milk mix. And I needed my chocolate milk fix that day. And so I was rummaging around looking for another container of chocolate milk mix. And it wasn't anywhere to be found. But I did see another box. Again, back in those days, we didn't have. You know, come to think of it, I might actually be the reason why they have pre-measured packaging today, because I never paid attention to the actual quantities. After all, these are mixtures, homogeneous mixtures, so a fixed proportion doesn't matter. Container of Swiss Miss hot cocoa mix. Now, again, back in my day, it wasn't pre-measured packages like they have today. They were canisters of the powder. And heck, I've made, hot cocoa before, and I opened it up and looked at it, and it kind of looked the same as chocolate milk mix. So you know what I did? I took that Swiss Miss hot cocoa mix and got my heaping tablespoons and put it into the cold milk and stirred. And stirred, and stirred. And if you've ever done that yourself, do you know what does not happen? It doesn't dissolve. Hot cocoa mix does not dissolve in cold milk. It just clumps together and sticks at the top. In other words, hot cocoa mix is not very soluble. It does not have a very high ability to dissolve in cold liquids like cold milk. You got to heat it up first. Now, with all that clumped sugar powder on the top of the cold milk, I wasn't about to waste it, so I just ate that powder by the spoonful. I have to say it was okay in a pinch, but I don't have a desire to do it again necessarily because it wasn't quite as good as the chocolate milk. Next time, however, I came home from school, I actually heated up the milk first. Hot cocoa mix in the milk and discovered, wowie kazowie, it is much better. Hot chocolate is much better made with milk than with just hot water. Hot water, it's not creamy enough. But milk, hot chocolate milk, oh boy. Again, my mouth is watering here. So, with these pictures, think again of solute, solubility, and solvent. Study those three words in the context of our high C and chocolate milk and hot chocolate. And perhaps that will aid in your understanding of the various words involved with solutions, that homogeneous mixture where one thing is dissolved in another, because they're not all the same. But here's the deal. We're going to use the rest of our time to get ready for our lab activity tomorrow by discussing a few lab techniques. We have to talk about some techniques that we're going to be using in the lab tomorrow. So let's begin with a word that you may not have heard of before, but you may actually have done it many, many times. And this word is called decanting. Decanting. Decanting can be defined as separating liquids and solids by pouring off the liquid. Well, what do I mean by that? Well, let me give you an illustration. As many of you know, I love the beach. Maybe even more than I love chocolate, come to think of it. As an adult, definitely I love the beach more than chocolate. As a kid, it was a toss-up. But if you've ever been to the beach and tried to build a sand castle when you were a little kid, maybe you discovered that dry sand doesn't work too well. And sand that is way too wet doesn't work too well. You've got to find that right combination of water and sand in order to build a sturdy sand castle. Now, if you've ever been to the beach in the middle of summer, you know it can get pretty crowded at the Jersey Shore. And so you might not be able to set up where I would always set up, at that high low tide mark, that perfect sweet spot for the best sand castle, building sand along the beach. I knew exactly the right spot to find for me and my family where the sand was that perfect combination. We used to build humongous sand castles and sand creatures, and everybody that would walk by would ooh and awe and want their pictures taken next to it, because we had a blast of building stuff out of the sand. And then when we built up a sweat, we'd go into the water and boogie board and body surf and stuff like that the rest of the day. But back to this word decanting. Where is this story leading? Well, if you had to get to the beach after the crowds were there, you might not have been able to get too close to the water, so you might have been farther back where the sand is dry and hot. And that would require you to go back and forth, probably with a bucket, a sand bucket, down to the water, back up, and you'd be bringing water up to the sand to make it wet until you could build something. Have any of you ever experienced that? Well, at some point, maybe you grabbed a bucket full of sand and water and brought it back to your workstation, your construction site, if you will. And so I want you to imagine, I want you to picture this bucket with sand and water. I have some questions for you. First of all, is sand soluble in water? You probably answered no. If you have any experience at the beach at all, you know that the sand itself does not dissolve in the water. So what sinks to the bottom of that bucket? The sand or the water? Again, if you've ever had beach experience, you know that the sand sinks to the bottom because it's more dense, and the water floats on top of the sand. Now, if you were an enterprising youth trying to build a sand castle, you wanted to get rid of that excess water before you dumped out that perfect combination of sand to put on top of your castle. And so how would you separate the water from the sand? Yeah, you'd simply pour off the water. That is probably your earliest experience of decanting. That's all decanting is. Decanting is simply separating solids by pouring off the liquid. Now, it'll be a little bit more involved than that tomorrow in the lab, but I think you get the idea. You got a bucket filled with sand and water. You pour off the water and you're left with sand. That's decanting. Now, let's move on to the next term, however, which is filtering. Filtering, by definition, is separating liquids and solids by passing through a filter, which you may recall from last year when we learned about cell membranes being semi-permeable, that a filter is a semi-permeable membrane, or a membrane or substance that allows some things through, but not other things. Now, again, if you think about that bucket of sand and water, and let's say you were decanting separating the water from the sand, I have another question for you. Do you think it's possible that some lighter particles of sand might have been suspended in that water and could possibly have flowed off the bucket top along with the water? Probably, yeah. So decanting might be generally effective, but if you want a lab grade effectiveness, you'd have to add another layer of separation, and that's where filtering comes into play. Because using filtering, you could totally separate the solids from the liquids, depending upon the type of filter that you might use. And there are different kinds of filters, which we'll go over tomorrow in the lab. Okay? So here's a quick illustration of decanting and filtering. If you look at the left, here we see a beaker with particles of a solid and a liquid of some kind, and you're just pouring off the liquid, just like our example at the beach. That's called decanting. Over on the right-hand side here, we see doing basically the same thing. We're decanting up top, but it's also going through what's called a funnel and filter paper, which I'll show you tomorrow for the lab activity. And doing both decanting and filtering is doubly effective. But in both cases, we're separating liquids and solids. But here's the deal. In the case of decanting and filtering, is it possible that some particles of something might be dissolved in solution and might drip through the filter paper itself and be part of this liquid down here, which is called the filtrate? In fact, I'd like you to add that to your notes in the diagram. This is called the filtrate. 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 So this liquid is the filtrate. Is it possible that there may have been dissolved substances into that filtrate? Maybe. And if so, there's one more lab technique for us to discuss to separate these substances, and that is called evaporation. Evaporation is the separation of liquids and solids by heating the liquid until it evaporates, leaving only the solid behind. Now, the liquid may or may not be water. It could be other liquids as well. But you can think of it in the context of water. And you know what happens to water when you heat it up. Well, if you heat it up enough, it will go through a phase change, going from a liquid to a gas. And by the way, do any of you remember what kind of heat is required to go from a liquid to a gas? Did you remember it was the heat of vaporization? And with water, it takes a lot of heat energy, 540 calories per gram, in order to turn a liquid into a gas. And if you do that through evaporation, if the liquid all vaporizes, all evaporates away, what are you going to be left with? Only a solid material will be left behind. Whatever that solid material that could potentially have been dissolved as a solute in the solvent of water, and that could only happen if that solid exhibits solubility or the ability to dissolve. So in the lab tomorrow, when we get to evaporation, we're going to be utilizing the Bunsen burners again. So review the steps on lighting a Bunsen burner to assist you with tomorrow's lab. So I encourage you to study those words today and also review the steps for tomorrow for tomorrow's lab activity. And so until then, I'll say bye-bye.